Let's talk about the Radian Snowman. Now, the Radian Snowman is really just a picture to kind of help us to remember the values for sine and cosine of our most important angle measures. The body of the snowman is a unit circle, so it's centered at the origin and it has a radius of 1. The top of the snowman is really just another circle that's meant for you to, draw a picture. So you put nose on it, maybe a top hat, whatever. But it's just for decorating. What we care about is the body, right? This unit circle. And like I said, since it is a unit circle, it has a radius of 1. So we already know 4 of the points that are on this unit circle. These ones. Because the circle has a radius of 1, this is the point 1, 0. Up on top, that would be the point 0, 1. The left-hand side would be negative 1, 0. And down at the bottom would be 0, negative 1. But what about all these other points that I have identified? Well, all of these points represent the most important angle measures on the unit circle. Right now, we're only going to focus on this first quadrant. In particular, let's start with the point that's in the middle. Now, that point that's in the middle is representing one of our most important angle measures, that being the 45-degree angle. If I were to draw that in, then here is our 45 degrees. Now, we can also draw another vertical line to create that reference triangle that we were using before, right here. Of course, this is a unit circle, so the radius of this circle is going to be 1, which means the hypotenuse of our triangle here is going to be 1. And we know a lot about a 45, 45, 90 triangle because I drew that vertical line. There's our 90-degree angle, meaning these two sides have the same length. And we know that if I went from the short side to the hypotenuse, I would have to multiply by the square root of 2. So if I'm going to go from the hypotenuse back to either of these sides, we have to divide by the square root of 2. And for both sides of this triangle, when we have the fraction of 1 over square root of 2, we should simplify that to being root 2 over 2. Root 2 over 2. That means that we have the coordinates for our ordered pair right here. That's going to be the x-coordinate of root 2 over 2 and the y-coordinate of root 2 over 2. Now, why is all that so important to us? Like I said, our Radiance Snowman helps us in remembering all of those trig values for our most important angle measures. So sines and cosines of 45 degrees. But which one is which? Well, we remember that sine is opposite over hypotenuse. So in this case, our opposite is root 2 over 2, and our hypotenuse is 1. When we simplify that, we get the root 2 over 2, meaning that the y-coordinate here is going to be the sine of that 45 degrees. And similarly with cosine, that's going to be adjacent over hypotenuse. So the x-coordinate is always going to be the cosine of 45 degrees. So that's all we need to know for the 45-degree angle. Let me zoom out and clean things up a little bit. Now we can do that again for our other important points in the first quadrant. So let's take the one that's on the bottom. Right? Again, it's representing one of our most important angles. Right? This angle right here, which happens to be 30 degrees. And when I drop that vertical line down to the x-axis, I've created a right triangle. In fact, it's a 30, 60, 90 triangle. This point is sitting on the edge of a unit circle, so the radius is 1, which means the hypotenuse of our 30, 60, 90 triangle is 1. And what we remember about the ratios in a 30, 60, 90 triangle is that when we started with the smallest side, we had to multiply it by 2 to turn it into the hypotenuse. Well, now that I have the hypotenuse, working backwards, we would just have to take it and divide by 2 to get this shorter side. And when we go from the smallest side to the longer leg, we take that 1/2 and we're going to multiply it by square root of 3. So this is going to be square root of 3 over 2. Since I have those two lengths of our right triangle, we do have coordinates, our x-coordinate being square root of 3 over 2, and the y-coordinate being 1/2. Now, relating this back to trig stuff, sines and cosines, remember sine is opposite over hypotenuse. So again, that y-coordinate now is going to be the sine of 30 degrees. Cosine is adjacent over the hypotenuse, so that square root of 3 over 2 is going to be the cosine of 30 degrees. I'm starting to see a pattern here. Let me clean this up so we can look at the last point. The last point we have to talk about defines another very important angle with an initial side right here and our terminal side over here. This would be our 60-degree angle. Now, when I drop that vertical back down to the x-axis, I created another right triangle that is also a 30, 60, 90 triangle. It's just that now we're focusing on the 60-degree angle instead of the 30-degree angle. This ordered pair is still on the unit circle, so we still have a hypotenuse of 1. And our ratios for our 30, 60, 90 triangle still hold. The shorter side is going to be 1/2, and the longer leg is going to be square root of 3 over 2. But what that does for the ordered pair is now our x-coordinate is going to be the 1/2, and the y-coordinate is going to be root 3 over 2. Looking at this in terms of sines and cosines, the sine of this 60-degree angle is going to be the opposite over hypotenuse. So again, our y-coordinate is going to be the sine, and the cosine is adjacent over hypotenuse, so the x-coordinate is the cosine. Let me clean this up one more time so I can point out a few more important features. In our Radiance Snowman, we identified 3 very important angle measures. We said the one in the middle was 45 degrees. The one on the bottom is 30 degrees. And the one on top was 60 degrees. And we identified each of these points by their ordered pairs. Each one of these ordered pairs has an x-coordinate and a y-coordinate. In each of those ordered pairs, the x-coordinate and the y-coordinate represented something important. The x-coordinate was always the cosine of whatever the angle was, and the y-coordinate was always the sine. And that's the way it's always going to be on our unit circle. The x-coordinate is cosine, the y-coordinate is sine. Another thing is that this is called a Radian Snowman, and it's called a Radian Snowman for a reason. It's not called a degree snowman. So we should be expressing our angle measures in terms of radians instead of degrees. Now remember, when it comes to radians, that in the entire circle, if we started at 0 and went all the way around, we would end up back at 2 pi, which means over at 180 degrees over here, that's going to be pi radians. If we cut that in half, this 90-degree angle that's on top, that's the same thing as cutting pi in half, so that's pi over 2. So inside of our first quadrant, when we cut that pi over 2 angle in half, we get this 45-degree angle, and that would be pi over 4. Since 180 degrees was pi, and we divide 180 by 3 to get to 60, that 60-degree angle is going to be pi over 3. And 30 degrees is half of 60 degrees, so half of a third is a sixth. Then we have the first quadrant of our Radian Snowman filled in very, very nicely. If you haven't done so yet, you should print off your own Radian Snowman and fill in the first quadrant with everything that I have written here. And practice using it. I want you to be able to look at this first quadrant so that if I ask you what is the sine of pi over 6 radians, you would look to your pi over 6 angle measure. And since sine is the y coordinate, you're going to recognize that this is 1/2. So what is the cosine of pi over 4? Look to your pi over 4 angle. The cosine is the x coordinate, and we get root 2 over 2. Or the sine of pi over 3. Look to pi over 3. Sine is the y coordinate. That's going to be root 3 over 2. And that works also for our 90 degrees and zeros, so that if we wanted to know what is the cosine of pi over 2, you find your pi over 2 angle, that 90 degree angle. And cosine is the x coordinate, so that'll be 0. So practice that. Make sure you have your Radian Snowman together, and the next time we'll fill in the rest of our Radian Snowman.